Hi everyone, today I'm going to be doing the worked examples from exercise 9.3. So this is the antiderivative of 1 on x. And look, the first thing that they give us is the general rules. And while we want to know that the antiderivative of 1 over x is log ex plus c, and they say when x is greater than 0. And you know why that is, because we can't log 0 and we can't log a negative. So it has to be greater than 0. When we get an example that has it's a little bit more involved, so 1 over ax plus b, so let's just say it's 1 over 2x plus 3, well then we can say that that is going to be 1 over 2 log e 2x plus 3 plus c, and then you'll notice this x is greater than negative b on a, and well, that's nothing difficult. It's just that you can't log 0 or a negative, so our implied domain there is that this has to be greater than 0. So if you then solve this, you're just going to get x is greater than negative 3 on 2, and you'll see that the b value, which is here, is 3. There it is. The a value, which is 2, is here, and it's negative. So it's a quick way to write it, but really you shouldn't need to memorize that. You can work it out pretty quickly. So look, let's look at the examples. And the first one is just asking us to antiderive this. And, well, we could write this as the antiderivative of 3 on 2 times 1 over x dx. And of course, this 3 on 2 could just come out the front. So, well, that's going to be 3 on 2 log e x plus c. So it's very straightforward. The next one may be a little bit more involved, but still not too hard. So what I'm going to do now, I'm going to take the 4 out, 0 to 3 of 1 over 2x plus 1. And then this just becomes 1 over ax plus b again. So when I antiderive this, it's going to be 1 over a, so 1 over 2, of log e ax plus b. And we're going to be going from 0 to 3. And what we can see here is that x is going to be greater than neg half. So you can do that is greater than 0, and you'll find it's negative half. And now let's go about subbing in our values of 3 and 0. So 4 times half log e, 2 times 3 is 6, plus 1 is 7, minus half log e, 2 times 0 is 0, plus 1 is 1. And then we get this half. I can take that out. Oops, not the negative. That. So let's just take that out. So that becomes 4 times half. And that's log e 7 minus log e 1. And remember, for subtracting logs, we divide. So 7 divided by 1 is 7. So we get equals 2 log e 7. And that would be our final answer. So a little bit more involved, but not really very difficult. The next one they give us, they want us to antiderive via recognition, and it's one of those ones where we have to differentiate something first. So I quite like these, and I think if you do a few, you get used to them, and they're really not that hard. So let's differentiate this first. We can see that we've got 2 parts and they're multiplied together. So this would be the product rule. So I'm going to say let u equal 1/4 x squared, and let v equal log ex, means v dash is 1 on x, and u dash will be 2 times 1/4 is half x. So the product rule, which you may have forgotten, dy dx, is going to be uv dash plus vu dash, and now you can just sub those values. Uv dash, so 1/4 x squared times 1 over x is going to be x squared over 4x plus vu dash, So that's x on 2 log ex. And of course, well, these x's can cancel, so I might just put that on the same line there. So now I can say that when I derive this, I get to this. And that's the first part of the question anyway, so I've done that bit. I'll get a mark for that. So then if I derive to go that way, it means I have to anti-derive to go this way. So I should write that. And what I will write is the antiderivative of 1/4 x plus half x log ex dx equals x squared on 4 log ex. So notice that here I've chosen to put it as, you know, the quarter and the half without the x in the numerator. It doesn't really matter. Either way is fine. I just, you know, for whatever reason wrote it the other way that time. Doesn't matter which. So let's see what is the same and what's different. So we're trying to antiderive x log ex. And what we see is that we have x log ex here. But it's got all that other stuff around it. So we need to get rid of that. We need to get rid of that. So let's break it into a couple of parts. So the first thing I'll do is the antiderivative of 1/4 x plus, take the half out, the antiderivative of x log ex. Don't forget the dx in both places. So I can see this x log ex really nicely here, and I can see all the stuff I need to get rid of. Let's just move this down a bit. So the antiderivative of 1/4 x is going to be 1/8 x squared okay, and it still equals x squared on 4 log ex. And now I can just subtract this like I usually would for really simple algebra. So just to save room, I'm just going to get rid of it over here, just so that we don't have to move that other one down even further. Now, so the only thing that's you know, in the way now is that half. So I'm going to be dividing by half on both sides. So that means keep, change, flip. So I'm timesing by 2 because it's a division of fractions. So this will go, and I'm going to get the antiderivative of x log ex dx is going to be 2 over 4 is half, half x squared log ex, and then 2 over 8 is 1/4 x squared, and that'll be that. Okay, the final question is in multiple parts. So this one's a little bit harder. Let's see how this one goes. So we start with the graph shown, and they're asking us to find the value of a, and we can see that a is the x-intercept. So if we're looking for the x-intercept, y equals 0. So it's not really hard, just you have to see that a is an x-intercept. So 1 over x minus 2 minus 3 equals 0. 1 over x minus 2 equals 3. And then 3x minus 6 equals 1. Add 6 on both sides, so 3x equals 7. And x divided by 3 on both sides, we've got 7 on 3. So therefore, a equals 7 on 3. So that's pretty okay, and clearly we're going to be using that in other parts of the question, so they've got us to do that first. So there we've got the x-intercept. So I might just write that here so that we've got it ready to use. The graph is shown, find the area between the curve and the x-axis from A to 5. Okay, so Well, 5 is a little close there. What I might do is I might just move the 5 so that we've got a nicer representation there so we can see a little bit more clearly. So this is going to be a negative area. So you can see that it's beneath the graph there. So for a negative area, we need to either multiply by -1 or we can flip the terminals. I like to flip the terminals, so that's what I'm going to do. So area equals, so it would be from 7 on 3 to 5, but because I'm flipping the terminals, I'm going to put the 5 at the bottom and the 7 on 3 on top. And I've got 1 divided by x minus 2 minus 3 dx. So let's anti-derive. So 1 over x minus 2, that's a log 1. So log e x minus 2 minus 3x from 5 to 7 on 3. Make sure your terminals are the correct way. And now we can just sub that in. Log e, 7 on 3 minus 6 on 3 would be 1 on 3 minus -3 times 7 on 3. Those 3's will cancel, so it's going to be minus 7. And we need to subtract when we sub in 5. So log e3, so 5 minus 2 is 3. And minus 3 times 5 is 15. So let's see. Now we get log e 1/3. We're subtracting the logs, so we divide. 1/3 divided by 3 is 1/9. So that's going to be log e 1/9. Minus 7 plus 15 is 8 square units. And look, just to point out, like, this is fine, but I mean, you could say that this is log e 9 to the power of -1 plus 8 square units. And in that case, the -1 would come out the front. So you would have negative log e 9 plus 8 units, or maybe 8 minus log e 9 units, or they could even have 8 minus 2 log e 3 units. And that's because 9 is 3 squared, so 3 squared, the 2 would also come out the front. So that's how we could get those. But look, any of those answers is correct. Okay, so that's that area. Find the equation of the straight line joining the points 0, 1 and A0. Okay, so let's pretend, for the sake of drawing the graph, the line, let's draw it like this. So this is 0, 1. And the equation of the straight line, okay, so we know that A is, 7 on 3. And there's our other point. So y equals mx plus c. And m equals y2 minus y1. So 1 minus 0 over 0 minus 7 on 3. So that's 1 divided by -7 on 3. Keep change flip. So it's going to be -3 on 7. So we've got y equals -3 on 7 x plus c. And let's sub in a point. This is the most, like, the easier one, so we'll do that. 1 equals -3 on 7 times 0 plus c. So c equals 1. So our line would be y equals -3 on 7 x plus 1. And there's no need to times everything by 7 or anything like that. That will be just fine. So now we've got that line, and I'll draw it on this one as well. So they want, find the other point of intersection between the line and the curve. All right, so there it is, and we're looking for this. So we've already got this one. So point of intersection, that is our light bulb thing where we think, that's where we equate, it's simultaneous. So what are we going to have? Our -3 on 7x plus 1 equals 1 on x minus 2 minus 3. So let's see, this is not going to be so pleasant. Let's -1 on both sides. -4. And then let's multiply everything by 7. So -3x equals 7 over x minus 2 minus 7 times 4 is 28. Now let's multiply everything by x minus 2. So it's going to be -3x times x minus 2. So we're going to be getting a quadratic here, equals 7, and so that will delete the denominator there, minus 28 times x minus 2. And now we will expand neg 3x squared minus, or no, plus 6x equals 7 minus 28x plus 56. And then, okay, let's take everything over to that side so that we can have a positive x squared in there. So that's going to be 0 equals 3x squared. Negative 28x minus 6x, that's going to be negative 34. And 56 plus 7 is 63. And let's solve that. 3x times x, and let's see. 9 times 7, negative 7, neg 9, yeah, I think that will be it. Let's see, neg 27x minus 7x, yep, good, equals neg 34x, good. So 3x minus 7 and x minus 9 equals 0. So what we can see, so 3x minus 7 equals 0, that's our point of 7 on 3. That was the value of a that we found before. So we don't need to find, we don't need to do anything with that. We already know it. The one that we didn't already know was here, so x equals 9. So we know now that here is 9, and they're next asking us to find the area between the two graphs, so trying to find this. So we don't actually need the y value for that, but they are asking the point of intersection in part D. So we do need to do that. So the x value is 9, and then we do actually need to find the y value, even though it doesn't help us for the for finding the area between the curves. So that if they didn't ask you to find the point of intersection, then you just would need the x value, and you shouldn't find it because it just is a waste of time. So when x equals 9, so what was it, y equals negative 7 on 3, no, better check, negative 3 on 7x plus 1. So it's y equals negative 3 times 9 is 27 plus 1, which is 7 on 7. So that's what, negative 20 on 7. So our point of intersection will be 9, neg 20 on 7. So for the sake of that part of the question, we needed that negative 20 on 7. So, but to be clear, for finding the area between the curve, we do not need the y value. So it's kind of, I guess, a little bit of a waste of time. So that neg 20 on 7 is here. So let's find the area. Just pretend that's a straight line. And this is 9. And this is our, what was it, 5 on, no? What was it? 7 on 3, 7 on 3. So 7 on 3. And this, we are wanting to find this. So our, to 2 decimal places, so that's going to be a CAS question. So for a CAS question with calculus, you would want to set up the area equation. So it's going to be from 7 on 3 to 9. And notice, when you're doing area between curves, you don't need to worry about flipping terminals or anything for negative areas. You just do the top curve or line minus the bottom. So, and now our top line is negative 3 on 7, x plus 1. And we've got to subtract this, which is 1 over x minus 2 minus 3 dx. So that whole thing there. Now, what I would do, that for my second line of working out, I would need to show the antiderivative. So that's going to be negative 3 on 14 x squared plus x minus log e x minus 2 minus 3x. And we're going from 7 on 3 to 9. And then, well, let's just neaten that up. So neg 3 on 14 x squared plus x minus 3x. So it's plus 3x, that's going to be plus 4x minus log e x minus 2 from 7 on 3 to 9. So for our marks, we would need this part, showing the area equation there. We would need this part, so the antiderivative, and if it was with CAS, you could just antiderive that on CAS. And then we would put our answer, which is to 2 decimal places. So that is actually, which I already found before. So the area is 7.43 units squared. And that would be our 3rd mark there. Okay, so that's that. And lastly, we just have one more bit. Using calculus, find the area enclosed by the line 2 over x, the x-axis, and line x equals -3 and -1. Okay, let's draw a picture. So something like that. And the line x equals -3 and x equals -1. So